In this example, we are asked to multiply and simplify the following product. So here we have x minus 3 plus 4i, all multiplied by x minus 3 minus 4i. Now, the first thing that we want to do here is rewrite this expression as the product of two complex numbers. And in order to do that, we need to distribute the negative in each one of the terms through the binomial. So doing this, we are left with the expression. We now have x minus 3 minus 4i, and this is all multiplied by x minus 3, and the negative times the negative produces a positive 4i. So we have the product of two complex numbers now, and we can see this portion here, x minus 3, which is the same in the second portion. That's the real portion of the complex number, and 4i is the imaginary part. Now, I want to pause for a cause here because we're observing a very unique product here. So we want to make a note that when we have a complex number, say a minus bi, multiplied by nearly the same complex number, the only difference being the sign in the middle, a plus bi, we refer to this as a product of complex conjugates. So these two binomials are complex conjugates of each other. And as we are about to see, when we multiply complex conjugates, we're actually going to produce a real number. So here we go. We're ready to start multiplying. Now, from our product here, we're going to apply the FOIL method. So applying our FOIL method, we see that our two intermediate terms are the same with opposing signs, so they're going to cancel each other out. And we can further simplify by rewriting our binomial product x minus 3 squared as x minus 3 multiplied by x minus 3. And then with our last term, minus 4i squared, we can rewrite this using the properties of exponents as 16i squared. Now, look at this. We have another binomial product that we need to expand by the FOIL method. So notice here, after we apply our FOIL method, we have two like terms that we can combine. And we also want to keep in mind here, the number I squared, we can recall, is equal to -1. So applying both simplifications, we can further rewrite this expression as our simplified binomial product, x squared minus 6x plus 9. And then we have -16 multiplied by -1 to produce a positive 16. And last but certainly not least, we can combine up our two like terms here, our constant terms, for a beautiful final answer of x squared minus 6x plus 25, which, as we can see, this is a real number. We took the product of two complex numbers and produced a real number, and that's again because we are multiplying the product of complex conjugates, which is also going to come in handy when we start looking at division with complex numbers.